and welcome back. So we're going to start on page 321 of your math book, and in this lesson we're talking about how we describe different quadrilaterals. If you remember, quadrilaterals are quad, Q-U-A-D, oh my gosh, here, let me try that again. Q-U-A-D, quad means, oh my gosh, I'm going to start this over. Okay, quad, why is it doing that? Oh my gosh, I'm so sorry, you guys. Let me take out my watch. Quad means four, and lateral means sides. And there's a lot of different words that we're going to use to describe them, and I want you to remember that you can describe a shape with more than one of the descriptors. So just like how I could describe myself as an educator, or more specifically a teacher, or more specifically a third grade teacher, or an elementary school teacher, or a teacher of room 7, all of those things are still true. Even though I'm a elementary school teacher in room 7, it still means I'm an educator, and these different descriptors can help us understand what we have in common and what we have different. So I can be an educator just like a professor is an educator, and we have that in common, but they're a professor of a university, and I'm an elementary school teacher, but I could be an elementary school teacher just like Miss Rios, or another teacher at our school, and then we have that in common there. You are a child, you're a human, you're a person, you're an animal, you could be a boy or a girl, you could be an athlete, you could be a reader or a musician. All of these things can describe you, and you can be described by more than one thing, just like all these shapes can be described with more than one. So, that's really important that you remember as we move through this. Different words that we're going to talk about are, there's parallelogram. Oh my gosh, I'm going to switch to a different pen tip because this is awful. Oh my gosh. Parallelogram. We're talking about trapezoids, rectangles, squares, rhombuses, and these are all types of quadrilaterals, and they all mean specific things. So let's go ahead and jump into it. A parallelogram. Earlier we talked about what lines are in math, and lines, remember, will continue forever in a direction. Now when you have two lines that could continue in a direction forever, like forever, and I really mean forever, and they would never touch each other, they are called parallel. If you have lines that, for example, if you look at these lines right here, this line eventually will intersect or touch with that line, right here. So these are not parallel. These ones, though, would be parallel. And if you're looking at the sides of a shape, if you can imagine that this would go forever that way, and this would go forever that way, those would never touch. And this would go forever that way, and this would go forever that way, and those would never touch. Now, you might be thinking, hang on a second, Mrs. Smith, I'm seeing these ones touch here. And you're right, these are intersecting, but these are the adjacent lines, which means like neighbors. We're talking about only the opposite sides. So imagine if they're like facing each other, you know, if you're sitting across from somebody on the opposite side. So let's look right here. These opposite sides would never touch. These opposite sides would never touch. These opposite sides wouldn't touch. These opposite sides wouldn't touch. Same thing here. Not touching each other, going on forever and ever. And when you look at the word parallelogram, you'll see there's those two L's in there. I think they did that as a little hint to remind you that those two L's are going to continue, right, and never touch. So parallelogram. And that's one way to describe a quadrilateral, if the opposite sides would never touch. Now, if you're looking over here, let me clean this up a little bit. It's not so messy. If you're looking over here, on these ones, these lines, just to show the difference, that, they're going to touch right there. This, these ones would touch a little bit off page right there, but they would touch. This, if that continued there, if that continued there, they would touch. Even though these ones would be parallel. Now this, only having one set of parallel lines, that has a special name. It's called a trapezoid, and we're going to get to that later. But with just one set, it's not a parallelogram. Over here, this one, it doesn't really have opposite sides in the same way, so it's even harder. It's like definitely for sure not a parallelogram. There's a lot of intersections going on there. And then this one, these two, these ones are parallel, but these ones are not, and that means it is not a parallelogram. What's that called again? It's a trapezoid. Good job. And then this one, it's got lots of sets of parallel lines, but the problem is it's not a quadrilateral, so it's not a parallelogram. Okay, so let's clean that up a little bit. Right there. A parallelogram is a quadrilateral with two sets of opposite lines that would never touch if they continued. All right, parallelograms. All right, now let's go on. Okay, now for this, I had to measure it on my paper book with a real ruler because I'm using my iPad here. If you have a ruler, you can go ahead and line up your 0 part of the ruler on the centimeter side. The centimeters, remember, are smaller than inches. And line it up and measure this. And for me, I got 4 cm here, 3 cm on this side, 4 cm, 3 cm. Over here, I got 3 centimeters, 2 centimeters, 3 centimeters, and 2 centimeters. On this, I got 1 on each of these, and I got 4 on each of those. So, take a moment and think about that. What did you notice? The opposite sides, they're parallel, but they're also what? They're the same length. The opposite sides, sides, oh my gosh, are the same length. as well as being parallel. All right, let's go ahead and move on. So now we're talking about rectangles. Remember, rectangle is another way to describe a quadrilateral, a four-sided shape. And in it, there's the word angle. And just a little fun fact for you, in German, the word right is recht. So this is literally saying right angles. So in every rectangle, all of the angles are right angles, just like we learned about in the earlier lesson with the polygons. Now, this one's turned on its side a little bit. It doesn't matter. These angles are all right angles, rectangles. Every single one of them. But they're also parallelograms because all of the sides will never, or the opposite sides would never touch each other if they continue. Oops, I meant to switch colors, purple. So, Adele says rectangles are a special kind of parallelogram. I think that makes sense. Parallelograms don't have to have right angles, but if it is a parallelogram and it has only right angles, that is what makes it a rectangle. So a rectangle is a parallelogram with all right angles. Okay, so that's just a more specific way to talk about a certain quadrilateral that has parallel sides and all right angles. Now, looking at the next section, these are all squares, and these are all rhombuses. I want you to take a minute and just look at those and see what you notice. What do you notice about the angles? What do you notice about the sides? Take a minute and think about it. I'm noticing here it says, Takeshi says squares are special types of rectangles, and Cora says rhombuses are special kinds of parallelograms. So now both of these things are true, and squares are also rhombuses. So the definition of a rhombus is it's got four sides, so quadrilateral. Oh my gosh. Try that again. So quadrilateral. It's also a parallelogram. Oh my gosh, it looks terrible. And all the sides are the same length, so it is equal sides. And there's one extra thing to make a rhombus a square, and that is that it is also a rectangle, which, if you remember that mini German lesson, means recht. All angles are right. They are all right angles. So a square is a four-sided shape. All the opposite sides are parallel. They're all equal length. And all the angles are right angles. So a square is a rectangle with equal sides. All of them, all four. And a rhombus is a parallelogram that also has equal sides. Now, I know this is a lot of information. We're going to keep working on this throughout the year. It's a lot to remember, and I mean throughout the unit and a little bit throughout the year. So just keep going with me, but it's a lot of labeling that we're doing right now. So, quadrilateral means 4 sides. Parallelogram means opposite sides not touching, right? Rectangle is right angles, and square is right angles. Oh my gosh, why does it do this to me? Right angles and all equal sides. This is the most limiting. So like in the same way that I could say I'm a human, adult, woman, Mrs. Smith. Like the square is the Mrs. Smith, the quadrilateral is like human, you know? Okay, so take a look at this one. I see it has 4 sides, so it is a, well, you can pause this now and go ahead and see if you can try to label them, or you can just continue with me. So this is a quadrilateral. The sides could continue and not touch each other forever, so that means it is a parallelogram. All of the angles are right or rect, so they are rectangles. Now, a square, are all of these sides the same length as each other? Well, this one's the same as that one, and this one's the same as that one, but they're not all equal, so it is not a square. Okay? Now let's take a look at this one here. This has 1, 2, 3, 4 sides, so it is a quadrilateral. Is it a parallelogram, though? Well, I don't really have opposite sides. They kind of, it's concave, so they would intersect, so it is not a parallelogram. I don't see any right angles, so it is not a rectangle, and all the sides are not the same, so it is not a square. And it's really important that you're keeping these definitions in mind because you don't want to accidentally label something with the wrong label. You can't just slap them all on there. It has to be accurate because we're doing math. Alright, so this one, let's see. Let's count the sides. 1, 2, 3, 4. It is a 4-sided shape, so it's a quadrilateral. It is, the opposite sides would never touch if they continued forever. So it's a parallelogram. With those double L's for parallelogram. I'm looking at the angles here. They are all right angles. They are all the sharp corners, so it is a rectangle. And then all of these sides are also the exact same length as one another. So that means this is in fact a square. Awesome. Okay. This one right here, count the sides. 1, 2, 3, 4. 4-sided shape is a quadrilateral. The sides, if they continued, would they touch these ones? No, they would not touch. These ones? No, they would not touch, which means it's a parallelogram. Looking at the angles here, ooh, these are not right angles. So is it a rectangle? No. And then looking at the sides, well, basically, if it's not a rectangle, there's no way it's going to be a square. It could be a rhombus if all the sides were the same. I mean, this one is also a rhombus, so we could throw that one in there too, this one above. If it's a square, it's for sure a rhombus, because a rhombus is a quadrilateral that has equal sides. But this one, the sides are different from each other in length. Oops. So it is not a rhombus. All right. Now, trapezoids, we talked about that super briefly. It is another kind of quadrilateral, four-sided shape, but it's kind of an offshoot of from the parallelogram. Now, a parallelogram has two sets of parallel lines. A trapezoid will only have one set. So, I just spoiled it for you, but here's one set of parallel lines. But then here we're going to, here we would have that intersection where they would meet, so that's a trapezoid. Here's another set of parallel lines, but then here, these would meet right there. And then this, I guess they'd meet over here actually. And then over here we'd have this set of parallel lines, and then way down there, those would meet there. So, I'll clean that up a little bit. Boop, boop. What do we notice about the opposite sides of a trapezoid? Well, only one set of opposite sides is parallel. The other set is not. Okay, so if we look down here, let's circle these ones that are trapezoids. Well, go ahead and try to find parallel lines. Now these ones, no, those will meet, so that's one set of not parallel, but that's two sets of not parallel, so not that one. This one, let's take a look. Here's one set of parallel lines, and then this set, yeah, they would intersect. So this here is a trapezoid. Here we have two sets of parallel lines. So this is not a trapezoid, it's a parallelogram. And then right here, this set is not parallel, but this set is. So here we have one set of parallel lines, just one, exactly one, which makes it a trapezoid. All right. Now, explain why the figures you did not circle are not trapezoids. They did not have exactly one set of parallel lines. That's why. All right, so that's it for today. There's an activity on Think Central for you to do for today and tomorrow, and if you have any questions, let me know, or you can call up a friend and work on this together. Good luck and have fun. See you later. Bye.